So worked example 2.24 on page 72 is a pretty interesting problem, one that's very similar to one we talked about in class recently. This is called an Atwood machine. It's a way of slowing down gravity, if you will. And the question here is I've got two masses hanging over a pulley, one's 4 kilograms, one's 6 kilograms. And the first question is, let's find the acceleration of both masses. So first thing we want to do is probably think about the forces acting on each mass. So here we have free body diagrams of the forces acting on the two masses. Note that I'm using the acceleration of gravity as 10 rather than 9.8, which is what the book does. The other thing you should notice is that the upward tension on each block that is happening from the string, that tension has to be equal on both of them. And it would be easy to think that the tension is 60 newtons on the 4 kilogram block, and the tension would be 40 newtons on the 6 kilogram block, but that would be incorrect because the string can't pull harder on one end than it does on the other. So the tension is going to be equal on both of them. The other thing that's really good to recognize, and this is probably pretty intuitive, is that the 6 kilogram block is going to accelerate in the downward direction, and the 4 kilogram block is going to accelerate in the upward direction. That will be true. You also need to recognize that they both will have the same acceleration. Since they're connected, they will both have the same acceleration. Sometimes I think it's a little bit easier to solve this problem if you look at it in a different way, so I'm going to draw it slightly differently. I think it'll make a little bit more sense. So here's another way of looking at this problem. I think the pulley sometimes makes things a little bit more confusing, but it's important to understand that you can kind of think of this as if the 60 Newton force, the weight of the 6 kilogram block, and the 40 Newton force are acting in opposite directions, even though the pulley makes it look like they're acting in the same direction. So now we can go ahead and solve for the acceleration here, and it's relatively simple. I like to do it by treating both masses as one system that has basically 10 kilograms of mass, and we have a net force, and we can just use F equals ma. So I'll go with the convention of the upward direction being positive, the downward direction being negative, and use F equals ma. Add the forces together, so 40 plus a negative 60 is equal to the mass times the acceleration, and that gives us an acceleration of both masses of negative 2 meters per second squared. In this case, that's going to be in the downward direction. For the way I've done the second drawing, it would also be the 6 kilogram mass moving down and the 4 kilogram mass moving up in the pulley one. Now, if there's a secondary question that then says, what's the tension in the string? Remember, the tension has to be equal on both masses. And now I use the acceleration that we just discovered to find the net force on either mass, and that allows me to solve for the tension. So now using F equals ma, the net force on the 4 kilogram block is 40 newtons down and tension up, and I made, in this case, I'm looking at the pulley diagram, the upward tension is negative. And I know that it's accelerating upwards, so that's going to be, equals ma for the upward acceleration is negative 2, giving me a tension of 48 newtons. Now I can double check this on the 6 kilogram block using the tension also being 48 newtons and see if that net force yields another acceleration of 2 meters per second squared, which is a good way to double check. If the negatives and positives get confusing, just remember that we said that this block has to be accelerating upward, and in order for that to be true, the tension has to be greater than the weight, right? So I know that this tension has to be greater than the weight, and in order to make the 4 kilograms accelerate at 2 meters per second squared, it needs to be 8 newtons more than the weight, so that the net force is 8 newtons. Therefore, the tension is 48 newtons. Hope that makes sense.